Let's take a look at the second problem on the kinematics test, the second free response, number 16. And so again, if you want to just look at my solution here, I'm just going to scroll it up. And back, so in case you don't want to listen to me, you can just look at the images and figure stuff out on your own. I do recommend you read this over carefully if you're going to bother to sit and listen to me, and then join me again. So here we have a data table of velocity time for an air track experiment, and it says use it to complete the graph. And so I need to label my axes. And so time here, I chose to go 0.1 each time, which fills it up nicely because time goes from 0 to 0.6. And if you chose something else, that's okay as long as it's consistent and things are evenly spaced. And the velocity goes from 1.4 to -1. So I started down here at -1 and went up by 0.4 each time. But again, you could have gone by something else as long as it fits on the graph. Then down here, it says draw a line of best fit on your graph. Maybe you did that as part of A. You should have, because this data sure suggests a straight line. And so I drew my line so I have about as many points above as below. And then it says use my line to determine the acceleration. And so the acceleration is the slope of this line. And so I need to pick 2 points on the line. Notice a lot of the data points are not on the line. It does happen the way I drew mine, that the first data point is on it and the last data point. That's great, but don't count on that. Pick points on the line that are easy to read. And so 0 and 1.4 and 0.6 and -1 are my 2 points. And so the change in y, -1 minus 1.4, -2.4. Change in x, 0.6 minus 0, 0.6. I get -4 meters per second per second. Part C, we want to determine the distance that the glider went between 0 and 0.2 seconds. And one way to do that is to get the area under the curve. And so here's the x-axis. A good idea to draw that on because area under the curve means the area between the line and the x-axis. And it's a trapezoid. So the area of a trapezoid is the average height, 1.4 plus 0.6 over 2 times the base, 0.2 meters. You also could have gotten the average velocity, 1.4 plus 0.6 or thereabouts, divided by 2, comes out to 1. And so the distance is the average velocity times the time. Or I could use this big fancy equation here, since you know the acceleration. But a lot of people tripped up on this because the acceleration is negative. And so that's one problem with doing that. And then part D, they want us to figure out the distance the glider went between 0 and 0.6. And so that would be all the area that's shown on the graph. And so let's do the area again. So that also works. But again, you have to be careful. Here's our x-axis. You can see I drew it on my graph. And so the area is this, and that's positive area. And then this, that's negative area. Yes, you can have negative area. And so if we go back to D, I've got 2 triangles. And so the positive one, 1/2 the base times the height. And the negative one, 1/2 the base times the height, which is -1. And when you add that together, you get 0.12 meters. You could also use this fancy equation. Even though I said using the graph, I allowed that because the acceleration came from the graph. So as long as you used the acceleration you got from the graph. And so that would work, but again, you have to make sure the acceleration is negative. Or you can use average velocity, 1.4 plus a -1 over 2. It's kind of hard to see here, but the average velocity comes out to 0.2 times 0.6 seconds. You get the same answer. So 3 different ways. Try them all out. See what you got. And then we wanted to try and figure out what was going on with this experiment. We didn't see it. Somebody else did. But we should be able to figure it out. And so what did it do? It started off with some initial velocity and slowed down at a constant rate. and then momentarily came to a stop and then went back in the negative direction. And so the air track was tilted, and we gave it a shove up and started measuring when it was going 1.4. So it went up, slowed back down. And you had to tell me about all of this to get the point. You couldn't have just said slowing down on the way up. You had to say then it turned around and went back, something like this. So give that one another try if you had trouble.